So let's do this exercise based on this example where we have one RTU, one SICAM AK3, which has the configuration in Toolbox. So you should start by having this backup, this configuration, this you need for your migration. And then you need to consider what you have. So in this particular example, we have one CP 2016 main CPU. And this is equipped with one protocol element, M30, equipped with the firmware for 104, ET24. You have a second protocol element, Pre1, also with 104 communication protocol. You have a third protocol element, protocol 2, equipped with the 103 protocol for a firmware for the AK3. You have another instance of protocol, the protocol 3, with ETA4 communication protocol, a 104 communication protocol. Now, in this configuration, you can see that the CP 2016, so in the same rack, you have one module in the third slot with this binary input module, with this firmware. You have another module of the same type in the fourth slot. In the fifth slot, you have one binary output module with this firmware. And you have in the sixth slot, this analog input module with this firmware. You have also a CP 2019 communication processor equipped with firmware for 104 in the protocol 0, firmware for 650 in the protocol 1, firmware for 103 in the protocol 2, and firmware for 104 in the protocol 3. Okay. So we need to migrate this to a CP8050 system. So what we will have to do, we will have to remove the CPUs. The CP 2016, the CP 2019 modules. And we, instead of the CP 2016, we insert the CI2530, which will be connected with the LAN ports of the CP8050. Now, in terms of configuration, this means we will replace the CP 2016 with a CP8050, which should be equipped with, in the protocol 0, with the equivalent 104 firmware of the CP8050, which is the ETI4. For the protocol 1, we have the same protocol, 104, so we will have to equip it with the equivalent for the CP8050. Protocol 2, which is the equivalent for 103 master in the CP8050, is the 103 MI0 firmware. Protocol 3, same thing. Now, we know that the I/O modules are not connected directly with the master firmware of the CP8050, but are connected to the extended processing. So we will need one instance of external extended processing in this CP8050. So we will call it CI. This is the first extended processing unit or virtual CPU. And there we will connect one 8000 rack, the first one. And there we will have also in the same position, position 3, the DI2111, 12, whatever, and the firmware will be in this case this one for CP8050. For the next module, we have this firmware. Now, we don't have CP 2019. Actually, we already have the official replacement of the CP 2019, which would be the extended processing license. So this is gone in the configuration. And in this extended processing we have 4 additional protocol elements. So to make the engineering easier, we will use the same order. So we will use the C1 pre-0 will be equipped with the ETI4 and so on, exactly the same. So now it is clear what has been replaced with what. So we must create another RTU in the configuration. We have our original AK3. We must create our new CP8050 with its own region number and component, unique, and with exactly this structure. We have the CP8050, the protocol elements, we have the extended processing, we have the 4 protocol elements, and we have the rack 1 with the modules. This is the first part of the configuration. Now, in system technique, you have a lot of things to match between them. But the good news is many of the things you can copy and paste. So on the left, we see the structure of the AK3, region 1 component 10. On the right of the CP8050, region 1 component 1. So for example, the topology, you can see all the topology here. You can just mark it here and with right click, copy it, and then append lines with contents on the topology of the CP8050. So everything could be transferred quite easily. You can do it also with the stations, for example. Other parameters like baud rates and IP addresses or some other stuff you may need to check individually. But many of the work can be done on bulk like this in the system technique. So you could really configure your system quite fast in the system technique. This is a huge part of the work that could be done in a matter of minutes or not many hours. Now, let's talk about the images. So in this case, let's see one example. We have here one signal that is coming from periphery. Okay, so this signal is coming from the AK3, which is region 1 component 10, from the binary input that is in the slot 3 connected to the main CPU. And this is the binary input 00. So we need to migrate this signal to the CP8050. What steps should I follow? First, I must adapt the firmware. So the firmware that I have is no longer this BIS X26. It will be BISX86. Now that I changed this firmware, of course, it is still addressed to the AK3. So this firmware doesn't match with the AK3. So this is why this SSE is shown as invalid. So the next step is to point it now to the CP8050. So to change, in this case, the component number, it will no longer be 10, but 1. And in this case, remember the binary inputs are not coming from the master module, which has address 20 also. It will be coming from the extended processing, from the C1. So I need to change it here as well. So when I do it, then there are no more errors here. So I just need to go to every binary input, every signal in the system and reassign them, right? Okay, you could do it if you have a lot of time and you don't have anything better to do. But we are lucky that there is a very nice functionality in Toolbox, which is called bulk edit. So let's see how this could be done in a matter of minutes or less. So you can just select all your signals. You can select the root of where your signals are stored in the images and just call the bulk edit, accept for bulk edit. You can select now the cat reg component, basic system element, the system element, the categories, etc. that you need for that. and you have here all the signals or the links in the system. Now you can make a filter, for example. If you want to filter for the binary inputs, with this you are calling all the firmware that is this BIS X26, for example. So I just go to the first one, and I will replace it with the firmware for the CP8050. And now that I did this, I can select the whole column, and then I will go to the button fill in down. So this is apply to all the column, all these selected. Now I have this invalid in all of them, but this has been applied to all. Now I need to adapt to point it to the CP8050. So the component in this case, I will go to the first one in the row, and I select, now it's 1, and select the whole column and say fill down value. This is still invalid because it is pointing to the main CPU, the CP8050. But remember, the binary inputs are connected to the extended processing. So I select for the first one, the extended processing one, the 001, and I select the column, fill down. And now everything has been done for this type of binary inputs. So I can do it for all types of binary inputs, no problem. How it would be for communication signals. In this case, for example, for 103, I make the filter 103, and then I change for the first one. I look for the firmware 103 for the CP8050. Select the column, fill down, and this is invalid because we are still pointing to the AK. So I change the first component to the CP8050 and change all the row. And now everything is fine. And we must do it for every firmware we are using. For 6150, same thing. If we are using selective data flow routing, for example, also you need to do it. If you are using the centralized archiving, also for all functionality, for every firmware in the AK3, there is an equivalent firmware in the CP8050. This is what we need to find out at first, and then the work would be really easy to do and fast. Now, what else should we migrate? Logics. So if we have in the original configuration in the AK3 one KX logic, you can easily mark it and select copy to, and select it should be copied to the, for example, to the extended processing of the CP8050, and confirm. It will tell you, okay, you want to keep the same signals for that. Since we have really not created any new signals, the signals are still okay. We confirm, and that's it.